The purpose of this video is to demonstrate a few things in Python, specifically using Numpy and Matplotlib, which is hard to pronounce, but you'll see in a moment what it is. I'm using Python 3.8. If you're using Python 3.7, everything will work just fine. To download the Python, I have other instructions on doing that, but I'm assuming that you've got Python installed. And we're using the IDLE IDE. In other words, we're not using anything like Anaconda or Jupyter or anything. The reason we're using IDLE is, one, it's very popular, but two, it keeps up with the different versions of Python a little better than some of the other programs. So what we're going to do is use Python, the IDLE, and when we open that up, we get what you see in front of you right now. What I'm going to do is I'm going to create a new program. So I'm just going to go File, New File. And I'm going to go ahead and take this and put it to the right so that we can see both of them. Now what I'm going to do is I'm going to create a program that does some simple time value of money calculations. I'm going to be using Numpy, which helps us with different arrays and array math. And I'm also going to use Matplotlib, which is hard to pronounce, but I'm going to be using that to do some plotting. So what I'm going to do is import these. I'm going to import NumPy and say as NP. That means whenever I use NP in my programming, it means NumPy. I'm also going to import matplotlib.pyplot as PLT. So anytime I use PLT, it refers to the matplot program. And this is a very common plotting program. Now, if you don't have these already installed on your machine, what you need to do is use the Windows command to do this. And what you would do is open your command prompt. If you're looking for it on your computer, you would search for CMD, our command prompt, and then you need to go to the different directories here, and you're working your way down the directories to different subdirectories. Now, if I want to move directories, I use CD. So if I do CD ... it moves up a directory. If I do CD scripts, it'll go to the directory. So you can go back and forth in different directories. The way you install something is to do what's called pip install. And then you put the name. Now I've already installed NumPy, so it's going to tell me that it already has it. But if you've never installed it, it'll go through the installation process. And so it's checking to see if it already has it, and if it doesn't have it, it will install it. So let's go back to the idle here. And ideally, okay. I already have it installed, but if you don't have it installed, you need to install the NumPy and the Matplotlib. Now what you do is we're going to use NumPy to create an array. You'll see why when we get to some of the calculations, but I'm just going to call it periods. That's a made-up name. You can call it whatever you want. Equals the NumPy. Now watch this. A range. A lot of people want to put an extra R in there, but it means a range, not a range. And I want it to go from 1 to 30, stepping by 1. So if I operate this, what I'm going to do is see what I've got. I'm going to say print periods. And this will print the periods. So what I'm going to do is run my program. It's going to ask me to save it. Okay, so I'm going to save the program. Save it wherever you like to save things. I create a separate directory just for Python, and I'm going to save it as demo, and I'm going to call it future value, present value. Now when I run this, you'll notice periods is printed. Now you'll notice here what's happening is it goes 1 to 29. So I could go change that and make it see what happens if it goes from 0. So now I've got 30 and they start at 0. Or I could start it at 1 So these are our boundaries, and when it hits that boundary, it doesn't add one more. So if I do 29, you can see what it does there. So what I'm going to do is I'm changing this to 31. And so as I go up here and I run it, of course I'm going to have to save it, and now I've got my 1 through 30. So I'm happy. So what I'm going to do is I'm going to just comment this out so it's out of the way, because I don't want to have to print it every time I do it. And you comment out with the hash mark. Now I'm going to set a few things up here. I'm going to select a rate. Now I could set this up so that the user is asked for it, but right now what I'm going to do is just simply put some values in here, and I'm going to have an amount of 100. Now I'm going to use Numpy to calculate a whole bunch of future values. So the way I'm going to do this is I'm going to call them future values, because I have a whole bunch, but you can make up whatever name you want, equals numpy dot future value, which is a function within Numpy, and it looks a lot like what you do in Excel. I have the rate, I have periods, I have no payment, and negative the amount, and 0. So if you're used to using Excel, you see that it looks very similar. The difference here is that instead of operating on just one period, it'll operate on everything in the array. So when I do this, I've generated a whole bunch of future values. So if I go ahead and print future values, I can run, and there are the future values. So now I've created an array. So I'm going to go ahead and take this one and comment that out so I don't have to see them every time. Now I'm going to show you how to plot these, and you're going to find plotting is pretty darn simple here. What you're going to do is PLT, which refers to the whole Matplotlib library, PLT dot plot, couldn't be simpler than that. And now what I'm going to do is I'm going to put in my X variable and my Y variable. Now when I run the program, it would generate a plot, but I'm not going to see the plot unless I actually specifically say show it. Now there's a strategy to that in terms of Python, because many times you'll create a plot, create another plot, and so on, and then you want them displayed or saved as one document. So this way you can wait to show the plots and so forth. So if we go ahead and run this, so I made a mistake. Mistakes happen. So I put the wrong thing in here, so I'm just going to put an S there, correct that. And you can see where I can see where the error is in red. Run it. And there's my graph. Now I can fancy it up by putting labels in here, and the X label, the Y label, tables, and so forth. We'll do that in a moment. All right, so now I have an array called FBS. I created it by using the future value function within Numpy. I created first an array of periods, and then it'll operate on that array of periods to create a new array, so that new array of FBS. Then I go ahead and I plot that. Now what I'm going to do is do something very similar for the present value. Present value, as you can figure, is going to be very similar coding. And so I'm going to say PVS is equal to np.pv rate periods 0, and now a negative amount 0. Again, it looks a lot like the Excel command. Now what I also can do is I can plot this. So this time I won't make a typo. I'll do plot, PLT, plot, and now I'll do periods again, because I can reuse that, and PVS, which is my array of present values. Then I would do plot, show, and don't forget those two brackets there. So now what's going to happen is I'm generating two plots. So when I run this, you'll see one plot and the other plot. Well, sometimes we want to do a little bit more than that. So what I'm going to do is I'm going to go down here and do one more thing, which actually has a bunch of coding in it. But I'm going to generate a JPEG that actually has all this information, the future value and the present value graphs in it. The way I'm going to do that is I'm going to create something called Fig. It's a made-up name because plot.figure. Now what that does is sets up an object. So it's like it's setting up a space to put something in. We haven't put anything in it yet, but we've set the space. So now what I'm going to do is I'm going to say the first thing that I want to put in there, I can do Fig and add, and now we do subplot. Now these numbers here that I'm going to put in the brackets here, 2, 1, 1. The first number is the number of rows, the second one is the number of columns, and the third one says where do you want to put this first graph. And so you're going to put it in position number 1 in the graph. And how we generate the graph as AX1 plot, and now we put periods, and we can put the future value first if we'd like, doesn't matter. Now we're going to go ahead and have some labels set up, set X label, periods, and start right. And then we're also going to do, and these are pretty self-explanatory what they're doing here. Now in terms of strings, you can use a double quote or single quote, just be consistent as you open and close the string. And then we have AX2, set, title, compounding. So this is one of the graphs. We've put the X label, the Y label, the title for this graph, and we know it's going to be in position 1 of whatever we're doing here. Now we're going to do the same thing, but we're going to do it for the second graph. And we're going to call that AX2. These are made up names, so now what you'll find is most people use the same made up names for things. So if you go ahead and go online and start looking for help with these different commands, you're going to find people using the same darn names, the AX1, the AX2, Fig for the object, and so forth. You don't have to, but everybody does. So you might as well join them so you can get some help there easily by using the same language everybody else uses. So I'm just going to do the same stuff, hopefully not make too many typos. Now if you make a typo, it's not the end of the world, and basically you go back, fix the typo, rerun it. It's pretty simple stuff in that regard. Now I'm going to do something else here, and I'm going to go Fig, which is the name of the object here, tight layout. Now what that means is I want these graphs to be spaced so that you can read all the labels. If I didn't do tight layout, when I see the small version of this, it'll all be kind of scrunched together. When I expand it to the maximum, there won't be a problem, but in the small one, it'll be scrunched together. The tight layout allows me to see them very well, even in the smaller configuration. So now hopefully I have no typos, but if I do, we'll fix them. That's the nice part about this. Plot, save, Fig. So I'm going to save it. And it'll save it in the same directory as your Python program resides. Now there are ways to put it in different places, different locations, but right now just We'll just put everything in one place, and that'll make life easier. And then we still have to show it. So what I've got here is we created the range of periods. I inputted a rate and an amount. I calculated an array of future values. I plotted it. I created an array of present values, and I plotted it. And then I've set up a figure, a plot that I want. It's actually going to have two plots on it and hopefully space nicely. So let's go ahead and run it, see if there are any typos. I'm always encountering typos, so we'll see what happens. We get the first graph, the second graph. I have a typo because I wasn't precise on my name, so I'll go ahead and fix that. First graph, second graph, and there's the final product. Now we can also see on a tight layout, we can actually read all this. If I didn't do tight layout, the periods and discounting here in the middle would actually be kind of written over each other. But when you expand it like that, you can see what you can do. So that is basic creation of a program to calculate present value, future value, create graphs, and put two plots on one page.